Here are the solutions for the Chapter 4 study guide on page 273. So first, I'm just going to do a rough sketch of this parabola. First, I want to graph the vertex, and remember that the vertex is kind of like the center of the parabola. So the parabola is going to be symmetric about that vertex. So since the point -3, 3 is on that graph, I know the point +3, 3 is on that graph. So I can sketch it a little better. It's not going to be perfect. I'm just kind of roughly sketching those 3 points. For me to get a better sketch, apart from that, I really kind of need the aid of the equation. So I know I got my vertex. I can plug that into my h and k in my vertex form. And I'd really like to be able to figure out the a. Well, since I'm given at least one other point, namely the point -3, 3, I can temporarily plug that in place of the x and the y. And then I can use that to solve for my value of a, which the a is going to be kind of like the vertical stretch factor in this case. So when you solve for a, you get 1/3. So that means that my full equation is y equals 1/3 times the quantity x minus 0 squared plus 0, but I can just simplify that to be 1/3 x squared. You could also just write x squared over 3 if you want to write it that way, but it's just I prefer to write with the coefficient of 1/3 in front. When I talk about the transformations, it's not shifted up, down, left, or right because the vertex is at the origin, but it does have a vertical compression by 1/3. So it's going to be a shorter parabola. It could be shorter than the value than the parabola of just regular x squared, which I just kind of sketched right on top of that right there. You can graph this, and I graphed both versions of that just to see what the comparison is. And I'm going to use Zoom Standard to kind of compare to those. So the first one is the 1/3 x squared. The second one is the parabola x squared. And everything checks out with what we found out by hand. For number 2, again, I'd like to have the equation to be able to get a better sketch of it, but I can at least start by plotting the vertex and plotting that point. And since I know this is the vertex, I know that not only is 2, 1 in there, but I can go like one more value to the other side, and 0, 1 is also going to be in there. So I can, again, write vertex form, plug in my h and k into vertex form, and then I can just temporarily plug those in. After I do that, I can plug the x and the y and use that to solve for the value of a. So I can get my full equation of my parabola here by just simplifying my terms. There I get 1 squared. I'm going to subtract 5 on each side. I'm going to get a by itself, and you end up getting that a is equal to -4. Now, I could have maybe, since I see that my vertex is plotted and there's a point immediately to the right, you could have maybe gone like, use the kind of, I hate to call it the slope method, but it kind of works to find the value of a. But again, I just rather use the way that the one that always works is using the equation. But this equation is shifted right 1 and up by 5 because the vertex is at 1, 5. And it's also reflected across the x-axis, which I should say that first. First, it's reflected because I want to reflect it first, and then after I reflect it, then I move it to the right 1 and up 5. Because if I do it the other way around, if I say it the other way around, it's not exactly true. But it's a vertical stretch of 4 versus by a factor of 4 versus the other one. I left out the word factor there, so I'm going to include that. But it's a vertical stretch by a factor of 4 because it's really tall. The next one, this is, we're just trying to graph this equation, and I'm trying to get the axis of symmetry, the vertex, the domain, and the range. So I can plot some points here. I know that this is just a regular parabola. It's shifted down by 7 units. I can get a sketch of that just to confirm that that's what's happening. So I'll go ahead and use my graphing calculator to confirm it. Or I can plug in table values as well. And if you notice, if I plug in just a few points, the positive values, I'm going to try, I can get the right side of that parabola. I'm going to eventually test also the left side of that parabola. I'm going to plug in those same numbers except like the negative versions of them. So instead of 1, I'll type -1. Instead of 2, I'll type -2, etc. And you'll notice that it kind of mirrors the values right there because it's not shifted left or right. This one just happens to be centered at the x-axis because your vertex is the point 0, -7 there. So you can use the table to help you plot points, but I can see here my vertex is going to be 0, comma, -7. Therefore, my axis of symmetry is going to be just x equals 0. It's always x equals the x coordinate of your vertex. The domain is always all real numbers in every parabola. Always, always, always. Any polynomial function, especially like quadratic equations, the domain is always real numbers. And the range is only the values that are above my vertex, because this is a top opening or concave up parabola. So my range doesn't include values under -7, so I can either say y is greater than or equal to -7, or I can write it in interval notation right here. Don't forget to always put a parentheses next to infinity. For this next one, it's in standard form. It's a lot harder to graph, just without the aid of a calculator at least, so I'm going to use my little trick of -b/2a, which is the x coordinate of the vertex, or the h, if you want to refer to it that way. So I can find my x coordinate of my vertex using -b/2a. I simplify that, and I get -1. Well, how do I get the y coordinate of my vertex if I have standard form? Well, you take that x coordinate, you plug it into x in the equation, and then the y coordinate that it spits out is the k value or the y value of the vertex. And so if I calculate that, make sure that when you put it in your calculator, you put the -1 in parentheses. Because notice how if I don't put the -1 in parentheses, it gives me two values, two different values. So just make sure you put that in parentheses. And the vertex should be -1, comma 5. So my axis of symmetry is always x equals whatever my x coordinate of my vertex is. So I'm going to have x equals -1. And now I'm going to plot the vertex for starters. I've got the vertex. To get the rest of the parabola, I like to use table values. I can do the table values by hand, but I notice that my a in this case, in other words, the coefficient in front of x is 1, so it's just a regular parabola. So I can just graph exactly what a regular parabola does, except that this one shifted left 1 and up 5. Now, what if you didn't follow that? What if you're like, I have no idea, you went too fast there? Well, just use table values. Just plug in your favorite x values. I recommend, 0 is a good x value, 1 is a good x value, -1, 2, -2, 3, -3. And I can use the trace function as well on the graph, but it's just not super precise. So again, use table values. You can do it by hand. I choose to use a calculator to kind of help me out, but I can plug in all the convenient x values. I choose to kind of center it at -1. Here it's centered at 0. If you want to center it at -1 a little better, you can adjust your little table settings to auto-generate here, and I'll make sure the screen is centered at -1, because -1 is a vertex. See how those numbers are symmetric? It starts at 14, ends at 14, second number's 9, second to last number's 9. But if you want to do it by hand, you don't need to do all that on your calculator. You can just plug the x values by hand. Either way, do what you got to do to get a good sketch of that graph. Your domain is always all real numbers. Your range is always dealing with the y coordinate of your vertex. This is a concave up parabola, so it's all numbers bigger than 5. You could write it as an inequality, but I just wrote it in interval notation instead. Again, I have an equation for number 5 in standard form. Man, that's hard to graph, just like by looking at it. That 5 and that -3, like, they don't really mean anything, but I can get the h coordinate, the x coordinate of the vertex, or the h is what I use for it, by doing -b/2a, and then to get the y coordinate of the vertex, or the k, if you want to call it that, you just evaluate the equation or the function at that h value or at that x value of the vertex. And I can also, like, if I want to, let's say you forgot -b/2a. You can also note that, hey, a vertex is either a max or a min, right? If you know how to calculate a max or a min in your calculator, there you go. I get the same x and y value as I did from doing it by hand. So I can calculate the max. If it's a concave up parabola, you do the same strategy except with a min. Or if you use the -b/2a strategy, you get the same values regardless of how you do it. I don't care which method you use. I just care that you can figure out one way or another. Here I have it in decimal form and I have it in fraction form. I really don't care which way you say the vertex. If you like decimals, go for it. If you like fractions, go for it. The axis of symmetry is still x equals to whatever your x coordinate is. And our domain here is going to be the same. The only thing we have to calculate left is the range. But I'm just going to go ahead and graph my function. I can at least plot the vertex for now, and I'll show you something else. Maybe I want to get like a rough sketch. I can maybe find the x-intercepts. This is not necessary, but just one more trick. Well, maybe I want to have my x-intercepts. I notice that this graph hits the x-axis, so I can roughly plot like little x-axis right there. So I can like roughly sketch my parabola right here. Or again, I could just use like my table values to get some points, just like I did in the previous examples. I'm just trying to show you different things you can use in here. So your domain's always all real numbers. Your range is always including the y coordinate of your vertex. And since this is a concave down or a downward opening parabola, its y value is less than 3.25. All those versions are ways to write the range. You don't have to write them all. Just pick your favorite of those 4 ways I wrote the range. Fractions, decimals, inequalities, intervals, doesn't matter. All right, here we're taking the square root of a negative, which is impossible. You can't take the square root of a negative. Well, it's not real, it's imaginary. Here's me doing it by hand, but anytime you're dealing with stuff that has I as a solution, guess what? You can just use your calculator for it. So if you put your calculator in imaginary mode or complex mode, you can just calculate that in your calculator. The square root of negative 16 is going to be 4i. For number 7, again, I can calculate it by hand. If you don't like using a calculator, negative square roots are you're dealing with square root of negative 1. Square root of negative 1 is I. And so the square root of 9 is 3. I simplify that. I get 12i minus 2. Now I have this written backwards. What if I just run it in my calculator? As long as your calculator is in complex mode, it'll calculate that. We normally want to put the real part before the imaginary part. So instead of 12i minus 2, I'm going to rewrite that as negative 2 plus 12i. But either way, your calculators are great for dealing with stuff involving negative square roots or stuff with I. Number 8, I'm going to do it the long way by hand. I can FOIL this or ETF to ETOTS or ETOOF BTOTOF, whatever you call it. It's really just distributive property. So we can just distribute that. And I'm color coding it here so you can see what I'm doing. You can follow this along if you want. That I squared at the end, it looks like if I combine those two and these come out to a positive 14i, and the I squared actually can be simplified further, and you might not realize it, because I squared is square root of negative 1 squared. Well, square root of negative 1 squared is just negative 1, and you can go through that whole rigmarole. But why not just run this in your calculator? And actually, I'll make a little mistake here. I write negative 14i. That's supposed to be a positive 14i. But good thing I have my calculator to check, because I made a mistake, even though I know how to do it. It's supposed to be 31 plus 14i. Your calculator can handle imaginary numbers. It can handle negative square roots, all by just entering it in, doing that complex mode. If you want to do it by hand, go for it. But I prefer to just run in the calculator. Here again, I'm going to show you how to do it by hand if you want. I like to distribute that negative because otherwise I'll forget about it if I don't. So I distribute that negative, combine like terms. I'm going to add my real numbers together, my imaginary numbers together. I get negative 9 plus I. Or I can just run it in my calculator. I get the same answer if I do it in my calculator. So number 10, I'm going to caution you about this. If you have a newer calculator, you're not going to have any problems. But watch what happens when I enter this. I have a little bit of an older operating system. When I use alpha y equals to do a nice stacked fraction, it gives me an error. So if for some reason you get an error, if you try to do it with your calculator, instead of using alpha y equals, you should use the parentheses and like divide them like kind of the longer way. So like that's kind of the sideways fraction. And you notice I get the answer in decimal form. I can convert it to a fraction. And if you want to know how to get this by hand, you got to use something called conjugates. So if you want to follow along with this, great. But as long as your calculator batteries aren't dead, there's really no reason for you to do it this way. Okay. So we have to simplify this. And so I got to use combine like terms. Got to get rid of the i's. Doing a bunch of work, combining the I terms. I squared is equal to negative 1. And so You get a denominator of 5, you get 6 plus 8i all over 5, and that's how you calculate that by hand.